Dear students, today we will continue our practice on mathematics. So, practice 4, real numbers and number line, decimal representation of real numbers and absolute value. So, let's begin with real numbers and number line. Here we have the notation of number sets. N is a set of natural numbers. We know what is the natural number, numbers which we use to count. So for example, we can write the natural numbers as N is from beginning from 1, 1, 2, 3, etc. Yeah. So this is the set of natural numbers. The next one is the Z is a set of integer numbers. So here we have integer numbers, for example, 3 dots, and we have -2, -1, 0, 1, 2, etc. So this is set of real numbers, I mean integer numbers. Firstly, let why here we have 3 dots and here also 3 dots, because if we consider the uh, real line, so here we have, for example, if we take the middle of this line as point 0, so on the right side we have the positive values, yeah, 1, 2. If we write, for example, only integer ones, 3. If we want to add the fractions, we have, for example, here 3.5, yes, 3.7, etc. And on the left side we have the negative ones, -1, -2, -3, etc. So this is a real line, and here you can see the integer numbers are, here we have minus, for example, here we have -100, yeah. So -100, here another one. So we can write the set of integer numbers like this notation. So next one, it is Q. It is a set of rational numbers. So rational numbers are which numbers that we can represent by m over n. Yeah, this is the set of all rational numbers. I, it is a set of irrational numbers which you cannot represent in this form, and R, it is a set of all real numbers. So this is we denote by R. So we can see here the set of natural numbers belongs to the set of integer numbers, and the set of integer numbers at the same time belongs to the set of rational numbers. So we can see here the connecting with these three sets, and also we can see here Q and I, so the set of rational numbers and set of irrational numbers are belongs to the set of all real numbers R. Now let's move to the next section. This is decimal numbers. So I think you know how to work with decimal numbers. So decimal numbers, it is like such kind of numbers. For example, here 7.305. So it is it means if we want to write this number in fraction, so it will be 7, and here we have 305 over 1000. How many numbers here we have in denominator? We have such number of zeros, 30 here. And the next one, for example, 0. The third one, 615. So this is, we can write as 615 over 1000. 3 zeros. If we have, for example, -2.5, 1, it will be minus 2, 51 over how much? 100, of course, 2 zeros now. And we have the type of decimal numbers which we call periodic or repeating or recurring decimal numbers. And what is periodic or repeating decimal numbers? For example, let's consider the fraction 1 over 3. And fraction, it means division, yeah? So we should divide 1 by 3. So let's divide 1 to 3. So it is 0 point. We have decimal fraction here, yeah? And it cannot divide it, so that's why we need to add 0. And 10 over 0, it will be 3. So it is 3 times 3 is 9. If we subtract 1, 0, and 10 divided by 3, it's again 3. So 9, 1, 0, we need to add 0, etc. So what we have always these 3's, yeah? So we can write this is as repeating decimal fraction. So it's repeat, so the 3 repeating here, and we can write this one as 0 0.3 here point, and over 3 dot. It means 3 repeating. So, or here we have some examples. For example, the first one, 2, 34, 34, 34. Here we have 2.34 dots, yeah? So the first dot, it means over dot, I mean, it means the beginning of this repeating part. And the second dot, it means the ending of this repeating part. Here, the repeating part is just 34. And the next one, for example, 5, 2, 3, 3, 3, yeah? So here, the only 3 is repeating. That's why 5, 2, and 3 is repeating. And the next one, for example, 7, 1, 1, 0, 3. Here, the 1, 0, 3, 1, 0, 3, 1, 0, 3 are repeating. So that's why it will be 7.103. The first over dot, it means the beginning of this part, and the last one, it is the ending of this part. So this is we call periodic or repeating decimal fractions. Okay, now rational numbers. So the rational numbers we considered here, it is, for example, 2 over third or just 5, because 5 we can write also 5 over 1, or 10 over 2, for example, yeah? 10 over 2. This is 5. Or minus 4, we can also write as fraction a over b, where a and b are integers with b is not equal to 0, because dividing by 0 is not possible. So you can see here the examples to rational numbers, and here also irrational numbers we have. And what is irrational numbers? It is numbers, they cannot be expressed as a fraction a over b. So in our case, for example, square root of 2, this is equal to 1.41421, approximately, of course. So, and here the other terms we have, and also we have number pi, so it is 3.14, etc. So these numbers are irrational numbers, and we cannot express such kind of numbers as a fraction a over b. That's why they are called irrational numbers. Okay, now the next section, it is rounding of number to a particular number of decimal places. So round the number down if the first digit to be excluded is between 0 and 4. round the number down here, and round the number up if the first digit to be excluded is between 5 and 9. For example, 2.561, and we need to round to 3 decimal place. So 2 decimal place here. And what should we do here? If we round to 2 decimal places, it will be 2.5 and 6 just because the first digit is so I mean the last digit here, the third digit, it is 1, and if it is between 0 and 4, it will be just down here, so 2.56. And here also examples. For example, 3.625 expressed to 2 decimal places rounds up to 3.63 because the third decimal place it is 5, and if it is between 5 and 9, so or if it is bigger than or equal to 5, it will be rounded up, so it is 6.3. And the next example, for example, 3.62499 expressed to 2 decimal places rounds down to 3.62 because the third decimal place it is 4, and if it is less than 5, so between 0 and 4, it will be up, rounds down. It will be rounds down. So we have 3.62. I think it's clear with the rounding to decimal places. Okay, here another type, rounding a number to a particular number of significant figures. So significant figures here we have, for example, round the number down if the first digit to be excluded is between 0 and 4, and round the number up if the first digit to be excluded is between 5 and 9. Here, significant figures. So, for example, here 6,248.50052 rounded to 2 firstly, then 3, then 7, and 9 significant figures will be. For example, if it is rounded to, it means 1, 2. So it is just 6, 2, and other ones will be down because it is the next one is less than 5. So it's 4. That's why it's just 0, 0. If it is till 3, significant figures here we have 1, 2, 3, and we will consider the next one again. So the next one is 8 here. So if it is 8, it means we need to number up. So it will be 6, 2, 5, and 0. Or if it is 7 significant figures, let's move to the 7. So 1, 2, 3, 4, 5, 6, 7. Here 0, and after 7 is again 0. So it will be just this one, 6248.5. We will not write if we have at the end zeros in decimal fractions. So, and the 9 significant figures here, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 5, and after 5 we have 2, and 2 is less than 5. That's why we need to round the number down. So it will be just this one. Okay, the same work with this next number, 0.13546 rounded to 2, 3, and 4 significant figures. So if we begin with 2, it will be 1 and 1, 2 here. Yeah, so after point we will count. So 1, 2, and after 2 we have third term, it is 5, just third figure. So however it is greater than or equal 5, it will be round the number up. So we have 0.40. And for 3 significant figures, we have 1, 2, 3. Oh, so sorry, 1, 2, 3. This one. So and the next one is 4 here, and 4 is less than 5. That's why we need to round the number down, and we have 0.135. And the last one, 4 digits, it will be 1, 3, 5, 4 here now. So after 4 we have 6, which is greater than 5, and we need to round the number up here. So we have 0.1355. This is answer. Okay, now we have scientific notation. So we will use in physics and in technical scientific notation. And a number written in scientific notation has the form a times 10 to the power of n, where a is between 1 and 10, and n is a whole number here. So, for example, this number here, how many figures we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 figures here, significant figures, and we want to write it is with scientific notation. So in this form, a times 10 in hours. So here we can write it like 9. So it should be a, it should be from 1 and 10 till 10. So it will be 9.52. This three ones, and times 10 to the power of 11. So it means we have here 12 significant figures, and if we open this one, it will be the same one with this one, this number I mean. And the next one, for example, 0 point like this number. So how many here significant figures? 1, 2, 3, 6, 9, 12, 15, 18, and 21. So if we want to write it in the scientific notation, we have 1.4 times 10 minus 20 is degree now. It is minus 20 because the number is less than 0 here, and we can write in this form. For example, let's write any other example. 0.00026, for example. Yeah, so we have here that's 2.6 times 10, and how many? 1, 2, 3, 4. So minus 4. We will count this till 2. How many figures we have? 1, 2, 3, 4. That's why minus 4 is degree. Or 2, 5, 7. So for example, 0, 0, 0, it will be 2.57 times 10 the power of 1, 2, 3, 4, 5 fifths power. So we will count now after 2 how many significant figures. Here till this 2, and here after 2. Okay, this is scientific notation. And now let's move to the exercise. So here we have some examples to decimal, working with decimal fractions. That's decimal fractions. So um, the pronunciation, it will be decimal. The correct pronunciation is decimal fractions. So in decimal fractions we have, for example, in first case, the adding here, yeah. So just we need to add these three decimal fractions. So 2.3 plus 0.4, it will be 7 and 2.7. So then we need to add to 2.7 plus 40, 98. So after point should be point. I mean below this point. So we have here just 0. We can write at the end zeros, and it will be 8. So 7 plus 9, it is 16, and 1 in mind. So 2 plus 4, it is 6. It will be 7 and 1. So the answer is this one. Or we have the multiplication here. So 2.081 times 0.03. So just multiply this 2081 by 3. So it will be 3, 24, 2, and here we have 6. And now let compute how many figures after points together. So 1, 2, 3, 4, and 5. So we need to complete from the right side 5 digits. 1, 2, 3, 4. So we have just 4, and we need to give 1 0 to do 5, and here it will be 0.0. So the answer is 0.06243. And we have division here. 30 over 8 divided by 0.25. So how we divide? By columns, of course. So and here should be to do either our work. Let's do this part, the this divisor 0.25 as integer number, and it means we need to multiply 100 this one and 100 the 30.8. So here we have without point now, and just 0, and we don't have point here, and here also we don't have point. So now it's very easy. 1380 divided by 25. Just I think you can do it by yourself. Okay, now the next example. A ball was dropped from 6-meter high. So after each bounce it goes up to thirds of the previous height. So how high will be the ball rise after the third bounce? So for example, we have bounce here. So I mean ball. So ball dropped from 6-meter. The altitude is 6-meter here, and after each one it goes up to thirds of previous height. So it will be now, for example, like this, 2/3. So it means up 2/3. It means if it is 6, the next time it will be 6 2/3 plus 6. This is for the next time, and after this one again bones. So like this, and higher and higher. So we need to find after third time, after third bounce, how high will be the ball rise. So here after first one it will be after first dropping it will be here, I mean it is 3 times 2/3 plus 6, and then we need to multiply it by 2 over third again, and adding the previous height, and etc. And the last time we will do this, multiplying 2/3 from the previous height and adding the previous height. So we have the third height of the third bounds. Okay, now if a and b are two numbers with this condition, find the largest and the least value of a over b. So here, to find the largest value, we need to take the largest of numerator, it is 4, and the least of denominator, it is 1 over 2. So the largest value is 4 over 1 over 2. It is 8. So this is largest value. So now to find the least value, take here minus 3 as numerator, the least value, and from denominator, if we take, for example, the largest one, 3, we have minus 1. But if we write here, however, this is negative 1, so we need to take here also 1 over 2, and it is minus 6. So this is least value. We cannot take here 3 because minus 3 over 6 is minus 1, and we have minus 6 also, the as least value of this fraction. Okay, now write the following as a periodic decimal fractions. So showed one example as 1 over 3. Here the same ones. For example, let me show the 5 over 7. So we need to divide 5 by 7. It will be 0 point. Here we need to add 0 and 7, 49. Let's divide 5 by 7. Here 1, 0. Here we have 1. It is 7. So 3 till getting the periodic part of this number. So 3 and again 0. It will be 4, 28 now. So it is 2, 0, 7 dividing. So it is, we have here, so 2, 40, and then we have 6, 0. So it is now 8, yeah, 56, and here we have 4, 0. So we have here now the next one, it will be 5. It will be 5, and 5 times 7, it is 35, and then we get again 5. So we returned our given one. Here if we do 0 again, so we will repeat this part. So it means this one is the repeating part. So then after this one we have again 7, 1, 4, 2, 8, 5, and etc. So we have the repeating part 7, 1, 4, 2, 8, 5. So we can write 5 over 7 as 0.71428. So beginning of the repeating part is 7 and end is 5. So sometimes we can use instead of this over dot, just over bar. So for example, in this case 5 over 7 is 0.71428 over bar. So it also means this is repeating fraction. So we can use this over dots or over bars. Okay, now write the following numbers as ordinary fractions. So here we have 0.3 over dot. It means that's, and 3 it's repeating part. Yeah, and the main question here is write these numbers as ordinary fractions. How to get the ordinary fraction from repeating fractions? So we have the rule of moving to the ordinary fraction. For example, if it is 0.3, it's repeating part, so it will be 3. It will be in numerator, and how many figures in repeating part, and such numbers of nines in denominator we have. So here we have just 1 3, so here we can write only 1 9. One more time, how many figures in repeating part, such kind of numbers of nines in denominator will be. So for example, it will be 3 over 9, or if we cancel them, it is 1 over 3. Or the next one, 3.0 and 3. So firstly, let's show the next one, not this one. It will be later. So 4.11, yeah. So 2 dots. So here we have how many figures in repeating part 2? That's why 2 nines here. 9 9. That's only nines. This is rule of making the ordinary fractions. So, and in numerator it's just 11. So 11 over 99 over, or if we cancel them, it will be 1 over 9. Here we have 4, of course. 4 it's integer part. Yes, of course. So and for the next one, for example, here we have 3 dot, one more example. So other example, for example, 2.789, for example. Yes, so here is beginning of repeating part, here the end of repeating part. So how can we write it as ordinary fraction? It will be 2. So how many figures here? 1 2 3 figures, so it will be 3 nines in denominator, and in numerator it is just 7 8 and 9. Now the next one, 3. This is not same with these ones, because here we have without part, which is without the repeating part, so it is 0. Yeah, 0, it's not repeating part of this fraction. So here we have 3, this is integer part, and how many figures in repeating part? It's only 1, so it here just only 1 9. And how many figures after point till the repeating part? How many numbers after point and till repeating part? Such kind of numbers of zeros at the denominator. So in this case we have just 1 0, so one figure, and it means only 1 0 in denominator. Zeros, only zeros. So, and the numerator will be in the next form. So here we have 3, because this is 3 0 3, it is just 3. Yes, 3, and we need to subtract this part, but this is in our case 0, so it's just 3. If we cancel, it will be 1 over 3. And for example, the next one, 2.8 and 3. So here we have also only one, 2, it's integer part, only one figure in repeating part. It is just 1, 9, it means in denominator, and the one, only one figure after point till repeating part. It is only one figure, that's why only 1 0 here. And now 48, we will take the together these two ones, it is 48, and subtract this part. So it is just 8. So now the answer is 290, and we have here 75. We can cancel them. So, and let's consider the next one. So the last one here, 30.8165. So here, how many digits in repeating part? 30 is integer part. Here 3, yes, 1 2 3, this one. So it will be 3 nines here, 9 9 9. And how many numbers after point till repeating part? 2. So it will be 2 zeros now. And in denominator, we need to take all together. So 81 6 4 5, and subtract this one. So it is 81. So this is answer. If we subtract, we get our answer. So I think it's clear with repeating or periodic decimal fractions. So now the next number here, compute this example. So here we need to write all periodic decimal fractions in ordinary fractions, and then work with ordinary fractions, operations under ordinary fractions. And here also the same work. So firstly we need to write all these periodic decimal fractions in ordinary fractions. For example, in this case we have, in numerator we have, so here 9 0, and 83 minus 8, it is 75, and the next one is minus, so 9 0 again, and 46 minus 4, it is 42, and here in denominator we have 3 nines, or 1 over 3, and just subtract them and divide by 1 over 3, we will get our answer. Okay, now the next example, which numbers are rational or irrational? So we said that rational numbers which we can represent as a form a over b or m over n, so as a fraction. So here, which ones we can represent? This one, yes, of course, because it is square root and squared, it will be just 3. And this one also, because here 4th degree, so square root and 4th degree, it gives us 3 squared. We have integer numbers here, and these two ones are irrational numbers. And now, are these expressions rational or irrational? So first, let's begin with a1. We need to multiply two ones, so it is 1 plus, this is the formula, a plus b squared, 2 times square root of 5 plus 5. So it is 6 plus 2 square root of 5. So this is rational or irrational? This is of course irrational, because we cannot represent as a over b. And the next one, the b1, 1 plus square root of 5 over 1 minus square root of 5. Here we need to multiply the denominator, the conjugation form of this expression. So it means with plus to provide the formula a squared minus b squared. 1 plus square root of 5. If a squared minus b squared we will open, it will be a plus b, a minus b. And multiply to numerator also. 1 plus square root of 5. There is no changing in our example, but now our denominator will be the formula. So it is 1 minus, uh, 5 just, yeah? 1 minus 5, and our numerator is this one. Again, we can use the previous one. So previous example, it will be 6 plus 2 square root of 5. The answer is 6 plus 2 square root of 5 over minus 4. Is it rational or irrational? This is irrational number. Again, we get irrational number. But if you put here, for example, minus to the next one, we get the formula 1 minus 5, and this is minus 4. This is rational number. Okay, let's move to the next example. The fraction 53 over 70 can be expressed as this expression, and if x and y are integers, what is the value of x plus y? So let's begin with the denominator of this expression, 3 plus 1 over, so x plus 1 over y, and 53 over 70 we can write as 3 and 3 and here 72. Yes, because it is 51 plus 2, 53 will be. Yeah. And now can we continue it like 3 plus 2 over 70? Yes, it means this one. And equal, if we continue, 3 plus 1 over 70 over 2. Is it correct? Of course, it's correct. So now we can write this 70 over 2 as 3 plus 1 over. So here we have now 70 over 2. It is 8 plus 1 over 2. So now what do we have? We have the same form with this one. So our x is 8, our y is 2. So if we add them, we need to find x plus y. It is 10. The answer is 10. Okay, now round the number to 2 decimal places, 5 decimal places, 4, 3 decimal places. So 30.2, it is, if we want to round to 2 decimal places, it will be 2, 4, and after 4 it is 3, which is less than 5, and it will be round down, yeah, and it is just 30.24. If you want to till 3 decimal points, it will be 1, 2, 3 here. Now we have 30, and after 3 we have 6, we can do rounding up. 30.244 it will be now. And let's do the 5 decimal places, last one. So 1, 2, 3, 4, 5, and after 5 fifth digit it is 3, which is less than 5. So now we have just round down 30.243, 6, and 7. The next example, express the following numbers in scientific notation. The mass of Earth is this number, so it's equals to 5.98. And how many here digits? 1, 2, 3, 1, 3, 6, 9, 12, 15, 18, 21, and 24. So it is 10 the power of 24. This is mass of Earth. And here also we have the next one. The diameter of water molecule is equals to, if you want to write in the scientific notation, it is 3 times 10. 1, 2, 3, 4, 5, 6, 7, and 8. We have minus 8. 3 times 10 minus 8. So now, this is homework for you. You can solve this kind of examples by yourself. This is same with today's examples. They are same with today's examples. So here we have 8 examples. Okay, now the next section is absolute value. So what's absolute value? Let write me a definition of absolute value. So absolute value of A, it is A if A is greater than 0. It is 0 if A is equal to 0, and it's minus A if A is less than 0. So for example, absolute value of 7. So it is, however, 7 is our A and it's greater than 0, it's just 7. It's just A. So our A is 7. And let's write absolute value of minus 7. So here what we have, the A is less than 0 because our A is minus 7, and it should be minus A. So minus 7. So it is 7 again. So what we can conclude from this statement, so absolute value is always non-negative. So 7 and 7. For example, the absolute value of minus 123, this is 123 we can write as. If it is absolute value of 0, it is just 0. And the other case, we have positive values. So this is the definition of absolute value, and we can consider any examples. For example, absolute value of minus 5 plus absolute value of 2.1 and the minus absolute value of 37 with minus, for example. And what we get here? We have here the absolute value of minus 5, it is 5 just, and the absolute value of 2.1, it is 2.1, and the absolute value of minus 37, it is 37. So it will be minus 37 because in the middle we have minus 1. So we can calculate these ones and find the answer. So the equation connecting with absolute values and inequality, absolute value inequalities, we will do later on our practices. So now it's enough just knowing the definition of absolute value, and I think it's clear. And the next time we will continue our um, topics, our practices, and do your homeworks. And if you have any questions, you can contact with us in our discussion group. Thank you for attention.